is pre-calculus section 6.1 homework. First of all, problem number 42. Here's the drawing, and we're trying to find the length of x, the distance from the gazebo to the dock. And I'm going to draw in this dotted line, which represents a north-south line, is parallel to this one, this transversal. That line, we can see then that these alternate interior angles are equal. In other words, part of this angle down here is 41 degrees. Then we can take this vertical line, this transversal, that same vertical line again, and see that this other part of the angle is 28 degrees. Then if we just focus on the triangle we're looking to solve, we have length of 100. 74 minus 28 is 46 degrees. The angle at the bottom is going to be 69 degrees. We're trying to solve for x. So if we use the law of sines, sine of 46 degrees over x is equal to the sine of 69 degrees over 100. We can cross multiply and solve, and x is going to give us approximately 75.05 meters. This is problem number 43, and here's the drawing that we're given. Our goal is to find the bearing of the flight from Elgin to Canton. So if we put an origin up there, we are in essence trying to figure out what is that bearing. How many degrees to the west of south? We want to figure out that angle right there. One thing I can see is that because this angle is 40 degrees, continuing along, and then bring this vertical down with the alternate interior angles again, this angle is 44 degrees, so I know that much. Looking then inside of this entire triangle, I see that this angle down here at the bottom, 90 minus that 44 would give us 46 degrees. So then we could use the law of sines to help solve for some of this. In other words, the sine of 46 degrees over 720, sine of 46 over 720 is equal to the sine of, call that angle C, over the opposite length of 500. So then we could cross multiply 500 times the sine of 46, divide that by 720, and then the sine inverse of that gives us the angle C is about 29.9696 degrees. And I'm going to store that into my calculator. Or I can actually just take 180 minus that 29.9 answer, minus the 46 degrees, and I can find then the measurement of this entire angle up here. And for that I'm getting 104 degrees. So this whole blue angle is 104 degrees. The right side of it is 44, so 104 minus 44 means that the left part of this angle is going to be 60 degrees. And this gives us our bearing. We're not going directly south, we're going 60 degrees to the west of south, that bearing. This is problem number 28. It's a side-side angle example. So if you use the law of sines, you'll get angle C to come out to about 74.2 degrees. And because it's a side-side angle, I'd encourage you to then store that value, about 74.21 degrees, and then take 180 minus 60 minus this value for C. That will give you what's left over for angle B at about 45.8 degrees. Store that value as B. Then we could say the sine of 60 degrees over 9 equals the sine of B over little b. Cross multiply and solve for that one. We get that little b is about 7.45. So there is an answer. To see if there's a second solution, we're going to take 180 minus C to see the other potential answer for that one. And it says that C could be about 105.8 degrees. That's the supplement to this one. If we look at what's already given, at 60 degrees, that 105.8 plus the 60 is still less than 180. So there's something left over for angle B, which means there is another whole triangle. And in the second triangle, A is still 60, little a is still 9, little c is 10, but our new angle C, the 180 minus the 74.2, is 105.8 degrees. store this as your new value of C. And we can take 180 minus 60 minus that new C, and that gives us angle B at about 14.2 degrees. Store that as your new B. Sine of 60 over 9, sine of B over little b. Cross multiply and solve for little b, and we get about 2.55. So these are the two solutions for that side-side angle case. In number 36, we're just asked for the area, and because this is a side angle side, we have angle B, we have little a, we have little c. We can use the formula 1/2 times little a times little c times the sine of the angle between them. So 1/2 times 92 times 30 times the sine of 130 degrees gives us about 1,057.14 square units. We don't have to solve the triangle, we can just use that formula. And the same is true for number 38. We have another side angle side. So 1/2 times 4 times 6 times the sine of 120 degrees, and we get about 10.39 units squared.